Okay, hello everybody. Welcome to our lesson on topic 2.13, which is exponential and logarithmic equations and inequalities. We're going to do this first part one, these notes part one right here. We're going to do that in a series of 7 videos. They'll be shorter videos, but this way, whatever you're having a problem on or concerns with, maybe you need to go back and rewatch something, you won't have to rewatch an entire video. So let's get started. We've got properties of exponents. Now, these are properties of exponents that you learned back in Algebra 1, again, using them in Algebra 2, throughout all of your algebra to this point. So I'm just going to do a quick review. When you've got the same base, you're going to add the exponents. So you'll be able to combine these or multiply these two factors by keeping the base and adding the exponents. When you've got a base raised to a power and then that's raised to another power, that's called the power property. And when you have one base raised to a power, you multiply the two powers. So you retain the base and you multiply the powers. Then we have our negative exponent property, which we use quite often. B to the negative n is equal to 1 over b to the n. If I have a negative exponent in the denominator, I can make that negative exponent positive by moving it up to the numerator. And I'll just show you a picture of what I just said. If I have 1 over b to the negative n, I can make that negative exponent positive by bringing the base up to the numerator. So you just change the position of the fraction. And then, of course, we had our properties of logarithms, which we used in the last lesson, topic 2.12. And now, topic 2.12 is really important for exactly what we're doing today. So what we're going to start with is equations with only one log or an exponential function. If an equation or an inequality involves only a single logarithm, then you can solve simply by converting between exponential and logarithmic forms. This is a big idea right here. You can solve by converting between exponential and log forms. And the AP exam, your final exam, is going to depend on you being able to solve going back between one form to the other. Our first step is to isolate the exponential or log expression on one side of the equation and get your constants on the opposite side. Then you're going to rewrite the equation to the alternate form. So we're going to rewrite the equation to the alternate form, meaning if you have an exponential equation, you'll write it in log form, and if you have a log equation, you'll write it in exponential form. Step 3 will be solving for the variable, if necessary, and then step 4, you're going to simplify and or round your answer as directed. So again, always important for you to read the directions. Okay, example 1 says solve the following equations. Leave your answers in exact form. So that means no calculator. When it says exact form, that means no calculator is necessary, which is really good for me because I don't have my calculator handy. 4 to the x minus 2 equals 7. Isolate that exponential or log expression, meaning get the exponential or log on one side and the constants on the other. So I'm going to add 2 to both sides, and I get 4 to the x equals 9. Now step 2 says rewrite the equation to the alternate form. This is exponential form. We're going to write this in log form. So log form says log base 4 of 9 equals x. And that is an exact answer. So that's my answer. Now log base 4 of 9 is just some value that's between 1 and 2. And that's because, quick reminder, 4 to the first is 4, and 4 squared is 16. 9 is between 1 and 16. So x is going to be between 1 and 2. Okay, let's try the next. 2 raised to the x plus 3 plus 5 equals 26. We're going to isolate this exponential expression. So that gives us 2 to the x plus 3 equals, when I subtract 5, I get 21. Then I'm going to write this in log form. Log base 2 of 21 equals x plus 3. And if I want to solve for x, my last step will be to subtract 3 from both sides. So I've got x equals log base 2 of 21 minus 3. Okay, we're going to now work on this last problem. If you wanted to use it as a try, you can press pause and then see how it all turns out. Okay, welcome back. If you've just come back, I've got negative 10 equals negative 4 times e to the x. I'm going to isolate the log expression, which includes getting rid of that 4 in front of e to the x. So I'm going to divide both sides by 4. So now I've got that log, it's not a log expression, excuse me, it's an exponential expression. So we don't want any coefficients in front of it. So I've got e to the x equals 5 over 2. And then log base e is the natural log of 5/2 equals x. And that's our final answer. Now in the next video, we will be doing example 2.